What I've done once again is to type in a list of examples using all the functions. So let's take a look at the miscellaneous functions. Let's start off with coalesce. Coalesce finds the first item in a list of expressions which is not null. Null, null, A. A is the first value. Now what we're going to do is we're going to look at the decode function. What the decode function does is it reinterprets a value into another value for a list of consecutive values. What I've actually decided to use is the user constraints view. First of all, let's go and describe the user constraints view. What we have is constraint name, constraint type, and table name. I'm going to use those three columns. This is what I'm going to use in general for my decode example. The first thing I'm going to do is I'm going to go and look at the constraints view and see what we have in there, in the concepts user. What we have is table names down here, the names of the constraints, and the type of the constraint. The type of the constraint is listed as a single character. What I want to do is to reinterpret those single characters into something sensible. Let's make a quick check on the user constraints view to see what we have. The distinct function will go through this column and select individual or unique values from here. In other words, as you can see, we've got two C's. It will give me one C, and it will give me one P, one R, one U, etc. So it selects the unique values or distinct values from the constraint type column in the user constraints view for the concepts user. Unique values we have are C, P, R, and U. Now what we can do with the decode function is to decode C, P, R, and U. Now I know that the constraint type P represents a primary key. The R type represents a foreign key, as in reference. U represents a unique key, and C represents a check. Since I'm looking at referential integrity values or constraint types, I'm not interested in checks, so I'll use the default. So what I do, how I decode is to say decode the field called constraint type. If I have P, reinterpret to primary key. If I have R, reinterpret to foreign key. If I have U, unique key. If I don't have P, R, or U, I will simply default to the unknown value. The last value is always the default. The first value is the value that I want to decode from. So let's run this query. And here I have it. Here's, for instance, my venue table at the bottom. It has 3 indexes. The first one is unknown, which implies it's a check constraint. The second one is a primary key on the venue ID. And the third one is a unique key called AK venue underbar 1. Let's take a look at another table. For instance, the category table. The category table has an unknown constraint type, which is a check constraint, probably a not null constraint, and has a primary and foreign key. The primary key is the category ID, and the foreign key is the parent ID to the category ID, the self-join. For instance, the show table has a lot more constraints, since it has 3 foreign keys and a primary key. It has 4 check constraints. These are probably all not null constraints on all the keys, the primary and the 3 foreign keys. So that's the decode function. Let's look at greatest and least. So we're going to copy and paste these examples into SQL+. You can see that greatest returns the greatest value of 1, 2, 3, 4, 5, which is 5. Least returns the least value of the words 1, 2, 3, 4, 5. Why is 5 the least? Because alphabetically 5 is less than 1, 2, 3, 4. First of all, F comes before O, T. Also, the I in the second letter of the word 5 comes before the O of 4. Therefore 5, the word 5, is the least value amongst all these words. Now let's take a look at null if. As you can see, since the two values are the same, it will return null. Since these two values are different, it will not return null, but it will return the first value. The NVL function. As you can see, what's happened here is that for my null show dates, which are appearing at the end of my query, I've actually replaced them with the sysdate value. So the NVL function, when it encounters a null value, replaces it with whatever you specify. The last example is select user from Joule, and it simply tells me which username I'm logged in as. That's all the miscellaneous functions and what they do and how they work.